solving linear systems algebraically. There's two different ways we can do this. Let's give it a try. Right now we're going to learn the substitution method. So the substitution method is you solve one of the equations for one of its variables. Then you're going to sub that in. So let's take a look at what that actually looks like, because that's usually easier. Notice here are your two equations, and they say solve the system using the substitution method. The reason you would choose substitution is, look at this. This is a single x. If you had a single y, you would solve for y. If you have a single x, you solve for a single x. We have this x all by, it's a single x, so what we do is we take and we move the 3y over here. So let me grab a pen and show you the process. And so what we do is we minus our 3y from both sides. Okay, so now we get x equals 3 minus 3y, because these canceled out. Now what we do is we take this expression, what x equals, and we plug it in right here into the other equation. So I'll show you that on the next page. We're going to take this 3 minus 3y and plug it in right there. Okay, so on this page I'm going to show you, we replace the x with the negative 3y plus 3. Now we solve this just like we do any other algebra problem using order of operations. You must distribute your 2 first, so you get negative 6y and positive 6. And then of course you want to get, since you have your negative 6y, let me grab a pen real quick since they jumped that, negative 6y plus 6, oh that didn't look good, plus 6 plus 5y equals a negative 5. Combine your like terms, so that becomes a negative y. I'm going to write it over here. Negative y plus 6 equals negative 5. So now we're going to go ahead and subtract 6, so we get negative y equals negative 11, multiplying both sides by a negative 1, so then therefore we get y equals 11. So that's how you solve for the system. Now, we go ahead and we get y is 11. Now we're going to have to substitute that back in to the equation so we get what the x value is worth. So we have 2x plus 5 times 11 equals negative 5. So we have 2x plus 55, because 5 times 11, equals negative 5. Now, of course, we subtract our 55, because that's the opposite of adding. And you get 2x equals a negative 60. Divide both sides by 2. So x, therefore, is negative 30. So our solution is negative 30. Oh, boy. Negative 30 for the x value and 11 for our y value. All right. Let's go to the next question. Elimination method. Now, elimination method is used when you don't have a single x or a single y. Here you go. Look at these two. You said solve the system using elimination. Notice you do not have a 1x anywhere in here. You don't have a 1y anywhere in here. Therefore, you want to use elimination. Now, you need to get the x's or the y's to be exactly opposite of each other. See this 3x and the 6x? If I can make this a negative 6x, that will allow me to eliminate the x's. That's why it's called the elimination method. So I'm going to multiply this top equation, the entire thing, by a negative 2. Because by multiplying by a negative 2, that will allow this term to become negative 6x. And then the x's will be opposite of each other. Okay? So let me move this down. And notice, I would strongly suggest you go ahead and write the equations to the right. So you multiply this whole thing by a negative 2, so you get negative 6x plus 14y and equals negative 20. This one you're just rewriting. Now that you have this set up, go ahead and add the x's, you get 0. Add 14y and negative 8y, and you'll get, oops, they don't have it, so I'll write it myself. Okay, so this is 0. This becomes a 6y. And then negative, oops, don't forget your equal sign. Negative 20 plus 8, you get a 412, and you get, oops, negative, right? Okay, so now divide those sides by 6, and y will equal negative 2. Now, substitute it back into either one of the equations up here. any one of these, and I'm going to put it in the first one. 3x minus 7, and I put the negative 2 in where the y was, equals 10. So now I've got 3x plus 14 equals 10, minus your 14, and you get 3x equals, difference between here is 4, and that's a negative, and then divide by 3, and so my x is equal to negative 4/3. So my solution would be written as negative 4, oh boy, 4/3, comma, negative 2. All right. And let me move this on down. There we go. And they're just showing another way to go ahead and get those answers. And so we get negative 4/3, negative 2. And now we get to have you guys try it out. Now in each situation you have to decide if you want to use substitution or elimination. Only use substitution method if you have a single x or a single y. So like, let's see how that's 1x. I would use substitution on this one because it has a 1x. Move the 5y over and then take that whole expression, sub it in for x. All right. And then look at the rest of these. They don't have a single x or single y. So these would be elimination questions that you have to multiply either the top or the bottom by a particular number. Now, let's go ahead and have you guys pause your video and give it a try. Welcome back. Let's see how you did. The solution for this one is 1, negative 2. And you should have had on this one, grab my pen, that x is equal to a negative 9 minus 5y, and you should have substituted that back in for this x. Therefore, you would have 4 times negative 9 minus 5y plus 3y equals a negative 2, and you get negative 36 minus 20y to distribute it, plus 3y equals negative 2. We put these two terms together, negative 36 minus the 17y equals the negative 2. And of course you have to add your 36 to both sides. It's a long process, isn't it? And so we get negative 17y equals a 34. And we'll divide by negative 17, so y equals negative 2. Then you sub it back in, and so we have, I'll do it in the second equation. So we have x plus 5 times negative 2 equals negative 9. So you get x minus 10 equals negative 9. X. Add your 10 to both sides. And I'm running out of room here. X equals 1. So our answer, of course, is 1 and negative 2. Now, on this equation right here, I would have used the elimination method. I would have multiplied the top by a negative 3, and I would have found that the solution is negative 3, negative 2. On this problem here, I probably would have, this one's a little bit more challenging. This one you would probably have to multiply the top and the bottom questions. All right, and your answer would have been 11/4. And I think that's all we're going to do for today, and I will see you tomorrow.